Okay. Hello, everyone. Hello, who managed to join. We'll give ourselves just a couple of minutes to let everyone hop in, and we'll be starting. So let's just wait a couple more seconds, and we can move on. Yeah, I already see a couple of familiar names here. Hello. And obviously, this webinar will be recorded, so you'll be able to view uh, anything you've missed later on. But I hope all of you will stay till the end because we'll be having a session for the questions. We'll do our best to answer. Okay, we are a little bit past the mark, so I think I'll start now with the formal hi everyone and welcome. Again, thanks for joining us today. We are really excited to talk about phishing-resistant authentication and how organizations can finally move toward, true passwordless security. Before we dive in, I want to give a shout out to someone who's been instrumental in shaping this space, Nishant Kaushik, CTO of FIDO Alliance. Nishant has been a key voice in driving the industry towards modern password-free future, and a lot of the progress we are seeing comes from work he and FIDO community is doing. So with that, I'll hand things over to Nishant and allow him to kick us off.
Thank you, Bartek. And thank you, everybody, for joining this webinar. We're very happy to have you here. Um, and looking forward to talking a lot about the benefits that Passkeys can bring to the enterprise. Obviously, as Bartek mentioned, I am Nishant Kaushik. I am the CTO of the FIDO Alliance. The Alliance is an open industry association, and it was founded, I think, in 2013, if I remember correctly. Been around for a while, trying to tackle a very key problem, which is reducing the world's reliance on passwords, right? And I'm sure we can all agree the less passwords we have, the better. Um, and the FIDO Alliance, if you can move forward, Bartek, the FIDO Alliance did this by bringing together a large number of companies into the Alliance as membership to help drive this mission forward. And these companies span everything from the platforms to security vendors, obviously large number of enterprises that are both in the consumer space as well as the enterprise space. And they've all been working together within the Alliance to help drive this mission towards reducing our reliance on passwords. Next slide, please. And the way that the FIDO Alliance does this is in three ways, essentially. Number one, obviously, is the definition of technical specifications, basically creating mechanisms by which we have open standards available that can facilitate moving towards a world without passwords, which obviously meant we had to come up with, as an industry, alternatives that could address the problem. And from a certification perspective, that's the second pillar of the work that the FIDO Alliance does. Because in order to make these standards work and effective, we have to make sure that there is a way for the industry that is relying on these mechanisms to trust what they're working with, to trust the vendors, to trust the products, to trust the way that these things have been deployed. And so the FIDO Alliance, as part of the work that they do, develops certification programs, not just for the specifications developed with the Alliance, but for programs that are connected to the ecosystem around passwords. And we also do this the last piece is obviously market adoption programs. We are working very hard to make sure that everybody, all the way in the ecosystem, from the end users and individuals who rely on passwords today, understand how to move away from passwords. And by basically marketing the message, creating adoption programs for enterprises as well as consumer enterprises, as well as workforce enterprises, as well as driving the mission through definition of best practices, papers that help organizations understand how they can tackle the challenges that they may be facing. So as I've said, FIDO's been doing this since 2013, and they've been focused on this problem where we started from the perspective of how do we address both security and usability in trying to come up with an alternative, because obviously the only way an alternative would work is if it's actually usable. If we've had alternatives to passwords for a very long time. I'm sure if you've been in the security industry, you've heard the phrase, this is the year of PKI, many times. And using cryptography has always been a very key element in how people have thought about tackling this challenge. But the key element to make that practical wasn't just the cryptography and the security that it brought, but also figuring out a way to make it usable. And that's really what FIDO tackled. And it did this by, if you can make the build, Bartek, by focusing on standards that allowed for authentication to be built on public cryptography in a manner that relied on possession-based factors, that relied on simple gestures that the users could understand and incorporate into their authentication flows. And most importantly, by focusing on phishing resistance, because the single biggest issue with passwords, besides the burden places on the end user, is that it's highly susceptible to phishing. And that has been obviously the largest vector for breach and fraud that we see all the time in the news. So moving away from phishing susceptible authentication mechanisms and making sure that any alternative is phishing resistant has been a key focus of the mission in the Alliance. So that's where Passkeys came from. Passkeys are passwordless FIDO credentials based on the protocols that were built within the FIDO Alliance. And it is using public key cryptography in a manner where the end user doesn't actually have to understand that that's what's happening. We're trying to wrap public cryptographic credentials with a usability fabric that allows end users to easily deal with this using devices that they commonly use, like their smartphones or are familiar with. And over time, we've seen how Passkeys has evolved to try and address the mission. And we now have two kinds of Passkeys, essentially. You have synced Passkeys and device-bound Passkeys. And synced Passkeys provide some really important usability benefits to end users, but they can also be balanced with device-bound Passkeys that may be familiar to folks like that have been using things like security keys, like from various vendors, or you can even have device-bound Passkeys within the context of a mobile app. And I'm sure we'll be talking a little bit about that later in the webinar. So the goal with having this optionality was to provide enterprises with choice, right? Obviously, we want to make sure that we have good security solutions that provide the right usability, but not every enterprise is the same. Not every use case is the same. Not every threat model is the same. So making sure that we had some optionality and choice built into the model where enterprises can choose the right kind of passkey strategy that works with their requirements was a critical part of this decision to introduce, take what we originally started with, which was device-bound passkeys, and add the capability of syncing on top of it. So let's dive a little bit into what Passkeys is and how they work. Obviously, the goal being phishing-resistant passkeys. We started from this framework that the architecture for most authentication today is about the user interacting with a server. And that interaction requires the user and the server to have some form of a common, what is called a shared secret, right? Some common authentication factor that each side knows that can be allowed them to verify, and mostly the server to verify the user and not typically the other way around. And that was based on shared secrets, whether it's passwords, whether it's API keys, etc., in different models. With the architecture that FIDO introduced with the protocols, it introduced another layer in between, which was the authenticator. And that authenticator sits in between the user and the server and helps manage an authentication flow where that authenticator essentially will be the system, the artifact that holds a private key dedicated to that authentication flow. And this is based on public key cryptography I mentioned. So the authenticator holds the private key and the server will hold the corresponding public key. And it's the use of this private key and public key with each other that allows the authenticator to authenticate to the server on the user's behalf using public key cryptography in a manner where you are not replaying secrets, you don't have shared secrets, the private key is safely protected by the authenticator. All the server has is the public key, which if there were ever a breach at the service provider side, that public key isn't really very useful for anybody to be able to breach. So all these things you see, like have I been found sites where they're talking about password dumps and all that, those things become immaterial and irrelevant. And in order to use the authenticator, the user interacts with the authenticator using what is called a user gesture. So this user gesture allows the authenticator to make sure that the user is there as part of the authentication ceremony. And that user gesture is something, as I mentioned, that the end user is going to be able to understand and be familiar with. Most commonly, you will see this being used using device-based biometrics, like Face ID on your iPhone or your fingerprint authentication on your Android phone. It could be using a security key, or it could be even a device local PIN. The goal being that anything that the end user is using is local to the device that they have in their hand where the authenticator exists and not reliant on anything on the server. With the gesture, what that does is it allows the authenticator to unlock the private key and leverage it as part of a challenge response authentication flow with the public key on the server. And that challenge response flow, being phishing resistant, is a pretty critical aspect of that, because what that allows the server to do is present identity information of the server to the authenticator that allows the authenticator to ensure that the key is only being used with the genuine server. So there are phishing resistant mechanisms built into the protocols that prevent the private key from being used on a phishing site. The users, even if the user wanted to, they simply cannot use the private key against or at a phishing site, which thereby prevents phishing from happening. That is a pretty critical part of the FIDO protocols. And as I mentioned, one of the things that was introduced was the ability for the passkey to then get synchronized across all the devices that the user has within their control. And a key, the way that was done was by leveraging a familiar pattern that most organizations are familiar with, which is the use of password managers. So with Passkeys, we now have credential managers. Credential managers are highly secure. They themselves can be protected using strong authentication, multi-factor authentication, security keys, etc. And the key, the private key that the authenticator is using in this scenario is protected essentially by the security that the credential manager is providing. So it's pretty safe, but it also provides really good usability, because what it does is it allows for the end user to be able to access their private keys across all their devices that they may be interacting with the services, and also be assured that they're not going to get locked out of services if they happen to lose their authenticator, if they happen to lose their phone or anything. They can still recover their credential and basically regain access to all their services. So that was a pretty important usability element that got introduced with the synchronization capability. So with all of that, where are we today with Passkeys? What Passkeys has allowed us to do is really drive adoption forward. Step number one in that is to understand that Passkeys are now available everywhere that you may need them. They're supported on all the major platforms. They're supported on a variety, all the browsers. You can see that we are no longer limited in terms of where they can be used and where they can be available. And this has obviously driven a lot of the consumer services adoption that has happened today. So you see a large number of consumer services making Passkeys available to their end users. And I'm sure all of you have seen prompts when you visited your favorite services for asking you to register for a Passkey. And that has really driven up the adoption for Passkeys in the market. The FIDO Alliance has been working with our membership to track usage of Passkeys in the ecosystem. And on the next slide, you can see that what we have been able to do is find that not only are over 15 billion accounts and counting accounts are able to use Passkeys, but through research we've been doing recently and member surveys and data gathering exercises we've been doing, and that you can see through Passkey Central, we're actually able to track that there are now 3 billion plus Passkeys actually in use today across consumer services. So we've really come a long way. And this is an important element because after 3 years at this point of Passkeys having been introduced as the terminology for FIDO's replacement of Passkeys, what we're now finding is that Passkey awareness is pretty high. 75% of consumers are aware of Passkeys today. They're familiar with the term. They understand. They're starting to understand what it is and what the benefits it brings to them. And as a result, we're now seeing 68% of organizations say that Passkey is a critical deployment. Now, this has all been driven through the market adoption programs and the benefits that Passkeys has brought into the consumer space. But the other element of this is how that is therefore driving workforce adoption. Within the workforce, we now see a large number of organizations adopting Passkeys for two main reasons. Number one, obviously they see the security benefits, but they are also now seeing that their workforce understands what Passkeys are familiar with how Passkeys can be used for authentication, and in some cases are even demanding that Passkeys be used. So that awareness that the consumer side has brought has definitely helped the workforce in adopting Passkeys as well. And that is a pretty critical element that we'll talk about more in terms of how Passkeys can now address a lot of the security and usability issues that exist within the workforce for strong authentication. You can see on the next slide a few snapshots. There's a lot more information available on the FIDO Alliance websites. And we are constantly working through our enterprise deployment working groups to get additional understanding of different ways in which Passkeys adoption within the enterprise is not only being done, but how the benefits it's providing. We're seeing benefits like conditional MFA approaches, where, for example, as I discussed earlier, you see IBM supporting both synced Passkeys as well as device-bound ones, and then appropriately using the right one based on the threat model that they might have. You're seeing organizations like Alibaba having users increasingly switch over to Passkeys, and as a result, seeing cost benefits by not having to send as many SMS OTP verifications out, and the reduction in customer, or in this case, workforce reported issues. Just think about the reduction in password reset requests that enterprises can benefit from. T-Mobile really went strong on deploying YubiKeys as a way of protecting their enterprise services within their organization. And within the space of 3 months, they actually went through a significant effort to deploy 200,000 plus YubiKeys to their employees, vendors, and partners to really tackle the problem of phishing and cybersecurity breaches. So you're seeing all of these benefits within the enterprise. And one of the most common myths that we commonly encounter that I tackle at Authenticate is enterprises continuously talking about, hey, passkeys are built for consumers. They're not really appropriate for the enterprise. But in fact, some of the what you see on this slide and what you'll see on the next slide actually supports the idea that actually enterprises can benefit the most from using passkeys, because you're getting better user experience for login, reduced time for login, more efficiency, reduction in help desk costs, and obviously phishing resistance and better cybersecurity by using passkeys. And from a FIDO Alliance perspective, continuing to support enterprises in deploying passkeys within the enterprise is a key mission. We are moving forward by focusing more on adoption programs, continuing to work hard on improving the usability of usage of passkeys within the enterprise, especially in line with some of the security and compliance requirements that enterprises have within the workforce, and continuing to push towards passwordless so that we can all benefit from a workforce environment where we are not relying on passwords anymore, and we can all work more securely and more efficiently. There's certainly a lot more information that you can find on Passkey Central, where we provide a lot of information, not just from a developer perspective, in terms of how to roll out passkeys, but also a lot of the work coming out of our different working groups in terms of best practices, use cases, and patterns, and things like that. But with that, I will hand it over to Bartosz, because I believe he will dig into one of the main issues that you find when that organizations encounter when they're thinking about passkey adoption, which is, how do I deploy this within my enterprise environment where I have legacy architecture, legacy infrastructure? Can I do one? Do I have to do one or the other? Do I have to make a choice? But we obviously do not want organizations to have to fracture or separate their security infrastructure. And so I believe there are ways that and patterns that this can be done. And there are a lot of organizations like Secfense that have done a lot of innovative work to help organizations bridge that gap. So with that, I'll hand it over to you, Bartek.
Thank you very much, Nishant. That was very insightful. I would like to follow up on what you said. First, by saying what does phishing resistant actually means to me and to Secfense as a company. Well, basically, just reiterate what you said. It ensures that the authenticator is cryptographically bound to the legitimate origin, so URL or relying party, if you will. And even if the user is tricked into visiting a phishing site, the credentials won't be able to be replayed. I don't want to go too much into regulations. We had a very nice webinar again with FIDO a couple of weeks ago that covered this topic very extensively. I just want to mention two things about latest NIST publication, which clearly bound phishing resistancy to higher assurance levels. And it required non-exportable keys and origin binding. So basically the cornerstones of what FIDO is doing. What latest commentary did is stress that phishing-resistant methods, like the one FIDO introduced, are now the baseline expectation, not something that might be nice to have. So it's more of a requirement right now. But it's easier said than done, unfortunately. And while the concept is quite simple in its basis and very straightforward to implement, in the new software or new infrastructure when it's obviously properly planned from the beginning. The standard itself is not the challenge. What we at Secfense struggle with in our day-to-day work is figuring out how to apply it within the ecosystems that are fundamentally built around shared secret authentication. The single biggest blocker to phishing resistant authentication is that most legacy applications are basically hardwired to username and password and some sort of local credential stores. Retrofitting these systems with FIDO to WebAuthn often requires custom integration or replatforming projects, which can take several months or even more, even with a dedicated team. And even with that, the companies can hit blockers related to lack of skills, lack of experience, basically lack of dedicated APIs in legacy systems. And replacing is difficult and it's usually expensive. And obviously, it comes with its own set of risks. Also, legacy single sign-ons, legacy IDPs, can also prove to be a part of the problem, as many of those do rely on phishable flows. A nice example I found is a study published earlier this year by Abnormal Security, which talked about a multi-year phishing campaign against Microsoft ADFS. It did hit 150 organizations and it tricked users into handing over their credentials. Basically, what all phishing campaigns do, right? But what is more important here, it exposed inherent risks of legacy identity stacks, those that do not enforce phishing-resistant MFA on protocol level. And putting SMS or some other OTPs on top of legacy login is like putting a padlock over a cardboard door. The attacker doesn't really care whether they steal one set of credentials or several set of credentials, while the flows allow them to replay all of those. Passkeys, again, are not the problem. The problem lies deeply in the core of legacy authentication, which still relies on a text box with the caption password next to it. Moving towards password labs, it's not just a software rollout, right? It touches all identity infrastructure. It influences endpoint security. It influences user habits. It influences support expectations. And while there are many different approaches for passwordless rollouts, like those in the slide here, they do usually involve some sort of agent installation, a code change, or do not offer a true passwordless and still involve using passwords at some point. I'd like to talk a bit about our own approach, which revolves around traffic interception at the reverse proxy level. Because Secfence's main goal is to introduce passkeys to organization without the need to make any changes in their code base or in their environment. This kind of codeless, agentless approach is what makes us actually different from other vendors. So how it started? I want to set you off with a little bit of history, not too much, don't be afraid. The Secfense user access security broker was created as an answer to challenging authentication scenarios found usually in banking environment, where the technological stack tends to be this interconnected network of interdependent legacy services. This whole technological stack shows the history of acquisitions and mergers that happened throughout the history of these institutions. We figure out that by positioning ourselves as a reverse proxy between the users and the application itself, we can take over the traffic, apply our own policies, and enforce them before the actual authentication even takes place. This approach allowed us to introduce strong FIDO-based MFA without any application changes and without even considering what kind of IAM performs the primary factor of authentication. That way, we could cover all kinds of authentication protocols, LDAP, Radius, AD, including Kerberos, and even in a couple of institutions we work with, NTLM. Fun fact, one time we managed to use our broker to add FIDO MFA to a Flash application. So that was a first for me. But yeah, those are still somewhere over there. And this approach, this notion became what translated to the DNA of Secfense, enabling strong authentication without modifying the protected application. And the obvious next step was to start introducing passwordless authentication, as we are strongly aligned ourselves with FIDO mission to read the world of passwords. So a huge word, but it's actually very pleasing future. We developed three distinct ways of reaching this goal. The first one being Secfense IDP, where we position ourselves as an identity provider in some OAuth or OpenID Connect compatible environments. The premise here is simple. If you have an SSO-enabled application, you can federate the authentication to our service. It's nothing groundbreaking so far because Okta, Entra, and others also do it quite well. What we bring to the table here is that our IDP gives you the possibility to retain the ownership of your identities. Our IDP is more of an identity broker rather than a provider, as we do not hold any information about the users, apart from the public part of the passkey, of course. We do perform initial authentication in a passwordless manner, and in turn, we ask the on-prem Active Directory or API of some cloud IAM to confirm that the user that we just authenticated still exists in the database and, well, is in the security groups that they are supposed to be in. So this IAM independent solution allows to introduce full passwordless authentication for software as a service applications, VPNs, using their already available support for single sign-on protocols, while still making use of companies' own IAM, retaining the identities wherever the customer wants them to be, on-premise or in cloud. And this solution is designed to authenticate employees or contractors, so more or less internal authentication. One more thing we've been working on recently, further into internal authentication, is a solution we developed recently. And the motivator for this project was to allow users from a global domain in one company to log in into applications that are under local domain. So this was this bit of separation, and they wanted to retain this cozy SSO feeling they had when everything was under a single domain, and they used Kerberos and NTLM for single sign-on. So we created a sort of a front for SSO-enabled applications, which acts as a FIDO2 relying party, where users register with passkeys, and after initially authenticating themselves with local credentials, they can create this public-private key pair. And from now on, we enforce passwordless authentication, and the rest of Kerberos and NTLM communication, token exchange, and negotiation will be performed between our server and the application in user's stead. So in short, we perform a protocol translation and enable strong, user-friendly, and as Nishant said, unphishable authentication, while limiting the security exposure of less safe protocols. This solution turned out to be universal enough to be translated to other single sign-on environments and introduce multi-factor passwordless authentication over legacy protocols. So we're happy to implement such things. But what about customer IAM? And this is the question we were asked quite often, and we do have a solution for this as well. This one actually I will show you in a real life application we are very proud of. Because what we did is we introduced Passkeys in BNP Paribas Poland in their business offering, and we used the lessons learned from our IDP solution. This thing started first as one of those impossible projects, as the bank application consisted of two different vendors, one for authentication, one for the app itself. It had several different means of providing credentials and several different means of providing the second factor. And what was over there also was a custom implementation of SAML. Those of you familiar with banking infrastructure can probably imagine how complicated those networks, those interdependencies can get, right? So what we managed to do over there is we introduced a solution in the network which acted as a FIDO server, as a SAML IDP, as the bank IAM API consumer. This device, the server, along with just a couple of rules on a load balancer within the bank's network, provided a solution that added another, this time passwordless minimal authentication, along existing methods. And we did that without any changes, neither to the banking app or current authentication toolset. And with this solution, the use of the load balancer was the key, as it not only allowed to provide and inject all all UI elements to the application, but it also could recognize which SAML artifacts are FIDO specific and should be directed towards the Secfense server, and which should remain on their default routes. So we basically distinguish the flows here. So to reiterate the significance of this solution, we introduced passwordless authentication along existing methods in a complex banking infrastructure using one server and three load balancer rules. And here's how it works in practice. So when user navigates to the bank, they are being greeted with their usual login screen, and there is this mysterious button we'll probably use a little bit later. First time they log in, they provide their traditional credentials along with this, I can say it, horrible mask password. I hate this kind of login flows, but that was actually chosen by the user. You can see how difficult it can get. And after they put in parts of their password, they receive an SMS with a one-time password, one-time code, which after being input allows them to get in. Flow very familiar. But once they're there, they're being presented with the opportunity to create a passkey. And this is where it gets interesting. The flow here is obviously very simple. The user unlocks their Mac authenticator and bam, it's done. There is a passkey created. The user retains the private key. The public key is being sent to the relying party. And along with that, we can also manage the passkeys at, I think, up to 10 backups, etc. And what I want to stress about, every single button, every single UI element here that is related to passkey flow is being injected live from the load balancer using a technique called content adaptation. So not a single change, not a single line of code within the actual banking application, within the HTML, JavaScript, anywhere. So that's how they register the passkey. And now the second part, the one that is way, way simpler and allows the user to log in with passkey, unlock the authenticator, and hello, you are in. I love the comparison between the original way of logging in and the one that is right now after the project. It really shaves off the time you need to log in. Obviously, this project was not without its own challenges. The thing we encountered is probably a subject for another webinar, and I'm quite sure we will host those also. But I want to mention two challenges that are particularly interesting. Our approach to proof of concept, because we wanted to perform the friend and family testings on live systems. So we obviously needed a way to distinguish between the whole base of users and those that were pinpointed for the testing. And the first idea was to send some sort of a link that sets up user with the friend and family testing cookie in the bank communication, but it was discarded as quickly as we thought of that because we didn't want to encourage users to click links in the communication from anyone. So that would go against bank security and probably against common sense as well. We decided on opt-in list. It's one of our tools that we use quite a lot in designing policies for our broker. So basically a predefined list of users that when they were recognized on the page upon entering their login were presented with a cookie that in turn allow them to see the UI elements that were injected by Secfense. And this let us control the test group, keep it in check, and while allowing the rest of the users to experience the login with no changes. Another challenge, the one that was actually somehow um, shown a little bit by Nishant in his part of the presentation, was to meet the bank's compliance regulation. So the discussion between the usability of synced passkeys and the security of device-bound authenticators. Uh, Obviously, the bank was a little bit shy to use the full potential of synced passkeys through their own compliance reasons and some security concerns. But we didn't want to exclude mobile authenticators completely. We could do that using the AA GUID and allow users only to use, I don't know, crypto keys. But this was something we didn't want to do because then we would lose a lot of usability of mobile passkeys. So how to combine the idea of a device passkey with a mobile authenticator, which a little bit seem like a mutually excluding ideas. We managed to find a common ground, and by means of technical improvements, we created a way to allow users only to use the passkey on a device they created it on. So to make things sure and more reliable, if a user create a passkey on their iPhone, let's say, they will be only able to log into bank with the passkey on this device, even if it gets synced to the iPad that stays in the living room and the kids are using it to play games. Despite the passkey being synced to the devices, Android password, Mac ecosystem, Apple ecosystem, whatever, we kind of restrict the usage from all the devices. They can obviously create another passkey on another device from within the same ecosystem, but the sync issue will no longer be a problem. Regarding the mobile passkeys, that's also a challenge we face quite a lot for our different projects. And I personally consider mobile passkeys being the most convenient way to introduce passwordless to the broader crowd. After all, we all have our FIDO2 enabled authenticators somewhere in the reach of our hands, right? What's controversial about the current stand of mobile passkey is the aforementioned synchronization and the fact that the private material is stored somewhere else, typically in the vendor's cloud. This usually raises some red flags around our more regulated customers from more regulated environments. So, on the other hand, device-bound passkeys, like those stored in CryptoKeys, Yubico, for example, also have some flaws. No one obviously can dispute their security. The security of physical authenticators is unquestionable. And, you know, the aforementioned Yubico set the standards in the authentication world. But when it comes to somewhat large user bases, even limited to one company's employees, the logistic of delivering crypto keys can be quite cumbersome and often discourages those companies from going full FIDO. We in Secfense actually believe that there is no need to sacrifice usability for security. After all, the usability of the solution is how FIDO paved the way and introduced passkeys, right? So they improve the security without the usual degradation of user experience. And even better, in my opinion, the set experience was vastly improved with the introduction of passwordless MFA. So what we developed, in response to this challenge, we developed our own mobile authenticator, which acts as a third-party passkey provider. It's a mobile software which allows to use your handheld device as an authenticator, like you would with any other sync device. But what it does differently, it stores the private material exclusively on secure element of that mobile. So your private part of the passkey never ventures to the cloud. We call this solution mobile-bound passkeys, and it's the best of two worlds because you can use your mobile as an authenticator without compromising the security and still have a device-bound passkey. It's a quite simple application which provides the user experience of a mobile passkey, like you scan a QR code, you receive a push notification, and once you provide your biometrics or PIN, you are being authenticated. But in the meantime, the private part of the passkey is never leaving your device. So there will be no compliant discussion, for example, in which region of the cloud your passkey is being stored or what happens if the cloud gets compromised. So that was our approach to FIDO to passwordless. And if there's one message I would like to leave you with, it is this. Phishing-resistant authentication is no longer a future goal. It is some kind of an operational requirement, and it's achievable. And if you would like to explore the options on how to achieve it, please feel free to reach out to us at this email and perhaps pleasure yourself with a lecture of one of our reports on passkey adoption and regulations, whatever seems interesting to you. And really thank you for joining today's session. Thank you, Nishant, for your part, for your involvement. It was really interesting. And in the meantime, if you have any questions, feel free to use the Zoom interface. We'll try to answer them now. So we have one question here that is open, and thank you, Aaron, for it. Let me read it because I know that the attendees cannot see the questions. Maybe this is a good question for the end because he might answer it, but what about device bind OAuth keys? Better authentication is great, but as long as it can be bypassed by stealing authentication tokens, it feels like there's a still big gap in stopping credential theft attacks. Well, I think we answered that. There's there's really no viable way at the moment to steal a FIDO token and replay the authentication when passkeys are being used. Correct me, Nishant, if I'm wrong, but I think that's how it is. I haven't seen a viable attack on passkeys yet.
Yeah, so I think the question is asking not basically what the question is posing is a common question that folks ask, which is once you focus on securing the authentication credential, which in this case is the passkey, attackers obviously look for the next best thing, right? Which is, okay, that door is closed, so where's the window that I can break into? And so session hijacking is another attack vector that commonly comes once Passkeys has secured the authentication, flow. So there's a paper on the FIDO Alliance website that you can find talking about complementary technologies that prevent the session hijacking problem, which is all about stealing the OAuth tokens or session tokens that are created as a result of the successful passkey authentication. And there are complementary technologies like the W3C has a proposed standard called device-bound session credentials, or DBSC. And OAuth has something called DPOP, demonstrating proof of possession. Both of these are technologies that you can use in addition to passkeys as a way of securing the entire flow. So passkeys secures your authentication flow, but how do you secure your post-authentication session? That's where technologies like DBSC and DPOP can help. And so there, like as I mentioned, there is a white paper on the FIDO Alliance website that talks about this and provides you the kind of guidance that you're looking for on that.
Okay, thank you. That was a good answer. Got a question from Mark. Passwordless authentication. Where do you see this being used the most from a geography point of view? where are the laggards? So I think that's also one for you, right?
Sure. So I think while if you were able to see the list of services being on, it's actually being adopted worldwide at this point. We've seen tremendous adoption in Japan, for example, because Japan was very early in adopting Passkeys and pushing it out to the market.
So the Comore
I would
case, right?
say,
The bank that did the huge work over there.
yeah. And so there is a lot of adoption, I think, all over this point. I think largely the laggards are places where you are having to deal with organizations that I think Secfense is trying to address, with organizations that have traditionally been laggards because of the fact that making infrastructure changes, making infrastructure upgrades, changing their existing products and architectures are held back because of a variety of concerns, like whether it could be budgeting, it could be compliance and regulatory issues. Those are the things that typically could pull sort of the momentum back. And so I think that's an actually a really good reason why innovation from FIDO Alliance members and partners like Secfense is important, because it allows organizations to actually jump into the passwordless waters much more easily and much more viably. Um,
I
so
have
hopefully
also
that
one
answers the
insight on
question.
that. I've been struggling with the PSD2 directive recently, which is a European Union directive that basically is something that all the banks in Europe need to follow, and there are very technical guidelines. And what's very well, I would like to say fun in there. There's no problem, according to the regulatory technical standards, with MFA means like OTP over SMS or TOTP, and they are completely compliant with the regulation. However, when it comes to passkeys and passwordless adoption, well, you really need to dive deep into the regulation to argue for the passkeys existence in the banks. It will be changed in the newest PSD3 directive, but it's not published yet. It's not a standard. So there's also quite a work from our government to, or governments perhaps, to well, help us enforce this kind of authentication. I think NIST is doing a great job with phishing-resistant enforcement, like I mentioned in one of my slides.
Yeah, I think there's a lot of momentum towards phishing resistance authentication being made a much more central part of a lot of regulatory regimes. I think um, we've seen, for example, as you mentioned, NIST has done recent updates that highlights phishing resistant authentication, including passkeys, and talks about their effectiveness in these kind of regulatory environments. We've seen SMS OTP increasingly being written into regulation as a bad thing. So essentially, directives that from in recent regulations that say that banks and organizations, but mostly banks, need to stop using SMS OTP. We've seen this in I think in the UAE, we've seen this in Singapore, and absolutely PSD3, which is being worked on right now, is going to be looking at much more improved um, uh, acceptance of phishing resistant authentication, which would include passkeys, but it's not limited to passkeys. Um, I think from a FIDO Alliance perspective, we're all for anything that can address the passwordless momentum and push it forward.
Yeah, I think that's a great summary to this event. So let's do everything to push passwordless momentum forward. I don't see any more questions. Thank you very much for attending, and really thank you, Nishant, for helping us out here. It was a great pleasure having you during this webinar. And again, have a nice afternoon or whatever time it is at your place, and we
Yep.
hope to see you in future webinars.
Yep. Thank you. Thank you, everybody.
Thank you.